Hello, welcome to another Dr. Pi video.
So what are you going to be showing us today then?
Well, today it's back to school, September in England and, well, September everywhere, but back to school in England, bit of education. So I thought I'd open up a book, Hacking by Simon Monk, and learn a bit more electronics because I'm going to be needing that for my CNC project. It uses an Arduino, or rather Tinkercad uses an Arduino, but the lessons we learn here will equally apply to a Raspberry Pi. So yeah, off we go.
Get on with it then.
Okay, so we're going to be connecting up this circuit on Tinkercad. Well, you already have. We're going to be controlling the flash rate of the LED using the potentiometer, aka variable resistor. So this circuit is available on page 123 of Hacking by Simon Monk. It's a 10k potentiometer and it sends an analog input to the Arduino on pin A3 as per the diagram. Here's the code. So we declared A3 as a constant, the analog pin, and the output pin, LED pin 9, which is the digital pin on the Arduino. The map command just changes the standard units for the input. So we've got a range between 100 and 500 milliseconds for the delay rather than 0 to 1024, which would be the default. So the code's ready, and there we go, simulate. And the flashing, the rate of the flash, which is the period, there we go, speeds up when we adjust the resistance on the potentiometer. So it's an analog input going into the Uno, which then converts it to a delay, which then controls the LED. Boom, there we go. On another subject, something I was looking at yesterday was the use of pull-up resistors, which are very important with switches and LEDs. If you don't have a pull-up resistor, the switch will do what's called float. You'll have a floating value, which means it can end up staying high. So it's not a switch at all really, because it's given a high value even when it's off. This circuit's also available on Tinkercad. I'll put the link for this in the description below also, which you can then go to that URL and copy this and tinker with it. So we've got a push button which then tells the Arduino to set the output pin to high to make the LED light up. The serial print command will display the value in the serial monitor in Tinkercad, which we'll see shortly when we run the simulation. So when the button's pushed, we want it to be high. When the button's released, we want it to be low. So high will be a 1, low will be a 0, and we'll see that in the serial monitor. Here we go. So 0 at the moment, low, 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 low. Press the micro switch and we get 1s. It's just gone off the edge of the screen there, but there you go. I scroll across and you can see the 1s. Release and it goes back to 0. So that's all good. That's how it should be. That's using a pull-up resistor. Good. So if that resistor just below the switch wasn't there. Take it out. Just tidying that up. We'll run it again and we'll inspect the value going back into pin 2 on the Arduino. So I push the micro switch, the button, and we've got high value. Very high. High, high, high. And it stayed high because that's what is floating. Put the resistor back just to prove it wasn't a trick. Run it again. As soon as I press the switch, get a 1. As soon as I release it, goes back to 0. We don't have that floating value. So I hope that's been informative. Look up, pull up resistors, and we'll see you again very soon. And subscribe if you like this. Thank you.
Please subscribe or we'll steal your dinner money.